recording. So, okay, we're going to do this problem. Just take a moment to read through it. I'll give you a moment. Something about the population of moose. You ever seen a moose? They're gigantic. They're gigantic and they're huge. So, I already mentioned the formula for this one. We modify it a bit. We get rid of the n-1 because now we're dealing with like real world. So you'll see that it doesn't, it just works out nicely if you do that. Otherwise you have to account for it and it's a nightmare. So what do we got? A growth rate of 9%. Here's the thing, if you have a percentage as your growth rate, you need to turn it into a decimal when you plug it into the formula. So one of the first things you're gonna do is divide by 100. So you would plug in 0.09. If you plug in 9, then yeah, you're gonna have really, really weird numbers. So anytime you see a percent and you're using it in a calculation, divide by 100. All right, so it says the population in 2006 was this, and estimate the population in each year to the nearest thousand. So 2006 is like our term 1. So we want to think of it as term 1. We can say term 1 is term 2006. So I'm just going to write it like that so I can be like, oh, you know, it's the first year that I'm looking at the population, whatever. 28,927. And they just say, well, what's the population in 2011? So I think I was lazy and I think right, this is just a big thing just saying that we're changing the formula to n from n-1, the power, okay? It just works out that way in word problems. So here's me dividing the rate by 100. Okay, so I already mentioned that. The population grows by 9%. We're going to take 100% of the population plus 9%, yes. So your growth rate is 1.09. If you put in 9%, then it's actually, you're gonna get the wrong answer, right? So the population grows by 9%, right? So that means we have 100% of what we had the year before plus 9% more. So we add 1. Does that make sense? Because when you divide 100 by 100, you get 1. So we add 1 and we get 1.09 as our growth rate. It's probably the other place where people have issues on word problems. So everybody cool? Great. You guys also sleepy after lunch? Shouldn't you be like energized?
Yay.
What kind of lunch? You guys aren't eating McDonald's for lunch, are you?
I did eat anything.
Oh, good. Actually, fasting sometimes you get more energy. Oh, and look. There's no answer. I'm gonna have to write it. Go up. So I'm gonna start writing over here. What was the number? 28,000.
947.
Okay. Oops, and we're not finding 2006, we're finding 2011, aren't we? Right, it says find the population in 2011. So I'm going to call this term 2011. And now how am I going to find my n? Well, you can just go 2011 minus 2006, and you'll find out how many terms are between there. Is it 5?
Yeah.
Okay, so the rate is 1.09 raised to the power of 5. And if someone wants to get an answer for me, I got 44,508. Anybody want to confirm? Good check.
What did you say you wanted?
44,508.
I got that too.
Yep.
Excellent. And what is it, moose? Do you know the plural of moose is moose?
Yes.
You think it'd be meese or something, but it's moose. Alright, so part B says estimated in 2030. And then I love how it's like the 125th anniversary of Alberta becoming part of Canada. It's like some genius who like wrote the book is like, we can squeeze like a social studies fact in here. What assumption did you make, and is this assumption reasonable? Okay, so look, you did a little survey for 5 years, and then you found this was the growth rate. And now here you are, like 24 years later, figuring out the population based on that. What is an assumption you're making?
That the population growth rate stays the same.
Right. So maybe there's something special about these years, like maybe there was lots of rain and there was lots of good crops or something and whatever, and there was lots of food. So maybe maybe that's a really high growth rate compared to the average one. You don't know. So it's just like, 24 years later, maybe the growth rate's different. But here you are assuming that it's still 9%. Okay? So that would be the assumption that you're making. So you could say something like for part B. And honestly, I don't even know, do you want to do this? Because it's exactly the same as before. Well, I'll just throw up the answer, but you'll say, we are assuming the population growth stays the same. We are assuming 9% is still, the rate of growth. And that's the thing with numbers. If you have hundreds of years of data, you can find a better average. If you have 5 years, maybe that's not very much. I think one of the criticisms of some climate studies is but we've only had good data for 30 years, and here we are predicting things, well into the future. I mean, that's a general math thing. I'm not taking any stance on climate change or anything. It certainly seems to be a thing that's happening, but I know in math, when you learn about models and stuff, one of the first things you learn is your data is only your model's only accurate if it is accurate within the data that you've collected, and as you start moving beyond and extrapolating, that's where you start introducing a lot of uncertainty. So that's definitely the case here. Questions? Did you guys like that fact?
Yeah.
Okay. So if we go plug it in again, go find term 2030. We'll start with that initial 2011 term, or 2006 term. Term 1 was 28,927. Great. And then the growth rate was that. And then we're gonna go 2030 minus, what was that term that we did, 2006, to find the n value, 24. Okay, so you'll go pop 24 in there, and I will just tell you. You get a 6-digit number, 228,844. So it's it's a lot of moose. If you get yourself a moose, it's 600 pounds of meat. They're crazy. It's a lot of meat. Any questions? Any hunters in here? No hunters? Great. Man, you guys are a blast. You guys do anything for fun?
Yes, actually. I play video games.
Video
Sometimes
games?
watch anime. And
Sarah,
study
you
a
play
lot.
basketball?
I mean, I was in school of bushwhackers, and I'd always get deer meat and
Oh, I miss deer meat.
deer meat and
Yeah.
duck jerky.
Yeah.
Deer.
Deer meat's very lean. Yeah.
It's so good though. It's so good.
Yeah, it is good. It's very healthy. Okay, aren't we so lucky to live in a place where I already did that. So we'll do 1.4 now. But we'll try. We got about 20 minutes before. I'm gonna play. I know, I got a lot of family in Europe, and camping and stuff is not. Camping's a big thing there because they don't really have a lot of nature. Whereas here we're just kind of surrounded by it. So hunting, camping, fishing. That's It's a big thing that Manitoba's got going for it for sure. Manitoba's beautiful. Too bad the winters are so long. Geometric series. Okay, so basically we're just going to learn a couple new formulas for sums now. Remember, the big difference between a series and a sequence. A series are when we start putting addition signs between the terms. And then here's the sequence where it's just like this. Oh yeah, I just saw it now. Okay, I'll give him a call.
Yeah, they phoned earlier there, so
Okay.
it came through to me, and I was like, oh, I'm in jail for
It
sure.
went to you. Okay, I mentioned your name, so
Okay.
that's maybe why.
Yeah.
Sorry about that.
Yeah.
All right, trying to buy some hot dogs from Giant Tiger. Okay. Where were we? Yeah, so that's the series. So here's the sum, right? Remember, Sn means the sum. Sum of the first term is that. Sum of the first two terms is adding up the first two terms. You guys get it, right?
Yeah.
Yes. So again, we don't spend a lot of time deriving this formula. Here is a formula for the sum. It's not obvious at all. Well, maybe it is, but who knows? So it's term 1 times 1 minus r to the n divided by 1 over r. That'll get you the sum. So it's on your formula sheet. See if you can locate it on your formula sheet.
You can put up for 2 seconds, please. Because it's much more.
Get 2 seconds. Okay. Okay.
What does that say? R.
It's t1 and then 1 minus r to the power of n. And then in the denominator 1 minus r. And it says here, right here, r does not equal 1. Well, what happens if you put a 1 in here? You're going to get 1 minus 1, and then you get division by 0, and can you divide by 0? No. The reason you can't divide by 0 is it just doesn't make sense. Like, how do you take a number and divide it into 0 groups, right? I used to tell my grade 9 classes, like, like De Niro has 6 pieces of chocolate, and he's going to divide it into his 0 friends. So, like, that is, how do you divide it into 0 groups, right? Like, how many pieces do you give to 0 groups? Division means breaking things into groups, right? So it doesn't make sense. That's why you can't do it. It's not like the world's going to explode. It just doesn't make sense. Questions? Okay. Here's example 1. Just determining the sum. It's pretty straightforward. Like, this unit's so dry. There's nothing to it. So yeah, what kind of information do we got here? Well, it says determine the sum of the first 15 terms. So they want to know that. So what's n? 15. Very good. Remember, n is whatever number is there. What's term 1? 40. Do we need to know r? Do we need to know r? Yeah, we certainly do. And so you can just use term 2 divided by term 1. Be careful, I see a negative there. Right, so when you find r, you're going to go negative 20 over 40. So your r value is negative a half. So watch out for the sign. Now I'm going to recopy the formula, if I remember. I think it's term 1, 1 minus r to the n over 1 minus r. Is that the formula? I think so. Yeah, excellent. So we have all the info we need, right? And you can always do that check, be like, okay, I know this, I know r, I know n, I know r. So I only have one unknown, which is this, the sum of the first 15 terms. So you can solve it. So we'll plug in the 40. Now be careful with the signs, because you got 1, subtract. Now r is negative, but also r is raised to the power of n. So before you figure out what happens here, you need to raise this to the power of n and see what happens with that. Now in the bottom, 1 minus a half is going to be the same thing as 1 plus a half, right? Sorry, like 1, I'll just write it out. So I know. Right? Like 1 subtract a negative number is going to be adding it. But certainly that's a good first step. Let's just plug everything in. Now you're going to get some big numbers. Forgot a bracket there. So this is how I do it. Like, first I'll figure this out. And I'll be like, okay, this is like 1.5, right? And you can have your calculator, so you can just go ahead and write 1.5 here. So here it is. That's 1.5. Then I would just go ahead and type this into your calculator. So figure out what this is. Like that number. And it's going to be a pretty big number. Is it going to be negative or positive overall? Negative. Why? Because you got a negative base raised to an odd power. So when I type it in on my calculator, I don't even put the negative in. I'm just like, it's negative, and then I just go 0.5 to the power of 15. What do you get? A big number?
Negative 3.05 to the power of 10,
10 to what power?
added to the power of negative 0.
Huh?
What?
Oh yeah, it'll be a small number, yeah. So what is it?
0.5. Negative 0.5. Or no, negative 0.5. Negative 0.5.
5?
Yeah, just 5.
Okay.
Yeah, 5.
Can you give me some confirmation? Like, this is a really small decimal number, so some of your calculators might spit it out in this notation. Yeah?
I just have a question.
Yeah.
So is finding R the same as you would find R in the,
The series in sequence.
cause you went.
Yeah. Yeah, so as long as it's geometric, no matter what, if it's a series or a sequence, you're still gonna find R by just doing 2 consecutive terms. Yeah. And then if it's arithmetic sequence, we don't have R, right? It's a composition. Yeah. So I just want to make sure we're okay on our calculators. You guys are just staring at me. So like, if you have your calculator, give it a try. Like you either get this, or your calculator might spit it out, you know, like this, something like this. Your calculator might do something like that. 1, 2, 3, 4, 5. It might give it to you like this. Anybody get it like that?
Yeah.
Is this even correct?
Yes.
Excellent. So calculator will give it to you one of those 2 ways. There's a really handy button on your calculator where usually it can store your answer. So when you type this in, hit enter, okay, and then usually you can go 1 minus and then find that answer button. So that means it's just, you don't have to retype that, like it'll remember for you. Did everybody find that button? Sometimes you have to go second function. Sometimes you have an actual button that says answer. But every scientific calculator will have it. Usually, look around the equal sign. Usually, like if it's a second function, it'll be second function equals. Did everybody find it? Ben, do you have that on your calculator?
I think so.
I think you don't like your calculator, I can tell.
Yes.
Yeah, you should get it. I've seen it from a distance. I don't like that one either. But yeah, so you go 1 minus that, and then just go times 40, and let me know what you get. And I could grab one of my calculators too and give it a shot. Because in my notes, I just jumped straight to the answers. So let's see, we got 0.5, you know, raised to the power of 15.
40.0012.
Oh, it's negative. Oh my word. So 1 minus the answer times 40. Okay, so I know it doesn't seem like much. Okay, so that's what I got. Divide by 1.5. And you're gonna get 26.667 or something. Questions? Everybody get that? I know it's kind of an ugly number, but. Everyone good?
So, are we doing on the top, 1 minus negative 0.5 to the power of 13?
I recommend you type this in first, and you'll get this.
Okay.
Then go 1 subtract and hit answer on your calculator, hit enter, and then multiply it by 40. So you don't have to keep writing a bunch of
Right.
decimal numbers is what...
So it's more like 1, if you were to negate the negatives, 1 plus answer. If it
Yeah.
was, if it was,
Yeah.
okay, sorry, I'm just trying to. clarify.
Yes, yeah, totally, yeah.
Yeah.
Yeah. Oh, thank you. Yeah. She gave it to you, or?
Yeah, she's gonna interrupt you, so.
Oh, what a nice lady. Okay. Very polite. So everyone's good with this?
Yeah.
Yeah, let's not make it like, I don't want you to be held back, like you can get this far and then like you have trouble typing it in your calculator and you can't get the answer. That just seems silly. So everyone's clear on how to use their calculator to get that? If you're not, like you'll just need to call me over because I can't interrupt the lesson because it can take about a minute to show you. So let's just do another one. I don't know if I have the answer to the try it yourself. But you guys have the exercises. I don't have the answer to that one. Let's just do another one. See if we can roll through these notes. We're gonna get behind. So, add the title. So this is one where we're gonna determine some terms, and they give us the sum of the first 10 terms and the common ratio, and they want to know the first term. So everything's going to be using that one formula that we have. So like when you read through this question, like I usually read it once, and then the second time I read it, I start thinking about, okay, so the sum of the first 10 terms, so that means S10 is this. that's the sum. You know, n is that number, so sometimes I'll write n is 10. And they told me that r is -3. And I only have one formula. So I'm like, okay, if I'm going to find t1, I sure hope there's a t1 in this formula. And there it is. So there it is. So you can do that little check. You can be like, do I know this? Yep. You know, do I know r? Yep. Yep. Do I know n? Yep. So I only have one unknown, so I can solve that formula. So now plug everything in, and you'll just have a bit of like algebra to do, I guess. So I don't know term 1. But then I go 1 minus, now in brackets, r is -3, n is 10. So you're always going to have to be dealing with, you know, doing this first. And it's always going to sort of be a really big number, a really small number. It's really annoying. So let's see. Because someone was saying, you know, just trying to figure out if it's positive or negative. Like, overall, this is going to be positive or negative. It's positive. So you're going to go 1 plus whatever you get. So on your calculator, you go 1 plus, and then you can type in, you know, 3 to the 10. Oh, I'm a liar. What the heck? This is positive, so you're going to go 1 minus, right? Sorry, that's a mistake. Maybe I need more coffee. Right? It's going to be 1 minus a positive number. So 1 minus 3 to the 10. So 1 subtract, and on my calculator I go 3 to the power of 10. So I get kind of a big number. I'm just going to go negative 29,524 equals, now be careful, it's term 1 times whatever I got here, and I got negative 59,048. Divided by, well, 1 subtract -3 is 1 plus 3, so 4. Now, if for work that's all you had and then you wrote term 1, I'd be happy with that. But visit your notes. It might pay off to just show a bit more of the steps of how you solve for term 1. Right, so you need to isolate the term 1, get it all by itself. So this needs to stay. So what's the opposite of dividing by 4? Multiply by 4. So I'm going to multiply this side by 4 and this side by 4. So 4 divided by 4 is 1. How do I, no, this number here is multiplying that. So what's the opposite of multiplication? Division. Okay, good. I never know because I always, lots of people have trouble. So I'm going to divide this side by that and this side by that. So on my calculator, I'm going to go this times that divided by that, and that will equal term 1. And when you do that, it's hilarious. You just get 2. Let's make sure that works for you.
Did you,
Yeah.
did you just do it at the same time?
I did that in my head.
Oh. Why are you such a genius?
So why did you take, because it was originally 1 minus -3. So why did it become just minus? Because it should have been.
Yeah.
1 plus.
So when you type this in, like negative base to an even power, you'll get positive.
Okay, so,
Right? So then you have 1 subtract a positive number, so you can have 1 subtract.
so
Yeah.
do the exponent first and then do the exponent.
Oh yeah. Yeah, guys, don't, bed mass is gonna apply all the time. So you're gonna do, you know, brackets first. So we went in the bracket and then we're like, okay, exponents. So you gotta figure this out before you can go 1 minus whatever. Yeah. Yeah, and like this is the kind of stuff, like, I mean, some of you guys, it could be a year since you did grade 10 math, right? Like,
It's been 2 years.
or longer. So yeah, like definitely worth going over. And that's why I like to show all the steps in the notes as much as is possible. Because you don't know where you're going to be at when you go back and look at your notes. Like you might look at them, you know, 2 months later, and if you skipped a step, then you'll be confused. Well, how did I get from there to there? And that wouldn't be very good. That wouldn't be very useful notes. So do you have any questions other than that? The stuff is pretty easy.
How did you get 2, 3, 1? I'm just
Yeah.
confused by it.
Oh, okay. Well, let me check on my calculator. Like, so like I would type in 4 times this. So you go 4 times, you know, the 29,524, and I got, like, I'll just kind of write it off to the side. That's what I got in the numerator, and then in the denominator I had this. So now I'm just gonna go divided by that number. Oops, I made a mistake.
It should be two.
So then you get 2. Yeah. Now it's really easy to hit the wrong button on your calculator, and that's gonna mess up everything. But does that seem to make sense? That is from there. That is from there. Yeah, honestly, the biggest mistakes I see in this unit is either people have just no idea where to begin, which is just like, okay, so you didn't do any homework. But then otherwise, it's like, you know, they plug in all the right numbers, and then they don't show enough work, and they just have the wrong answer, and they don't have anything in mind. So on your test, like, show as many steps as possible. They're drilling right underneath us. So, yeah. Any questions there? Like on the test, if you writing down the formula is good. Showing me that you plugged everything in correctly is really good, because I'm like, okay, so they knew what R was, you know, they knew what N was. If you jump from here to the answer to get it wrong, like you could, if this was like a 3 or 4 mark question, like you might only get 1.5 out of 3 or something, right? Because then I don't know where you went wrong anymore. But if you like, say you showed me, you know, this step, then I'm like, okay, so they evaluated this correctly, you know, they did that correctly, and then, you know, if you showed me the next step, or at least you have T1 equals this, and then you had the wrong answer, I'd be like, okay, clearly they typed it wrong into their calculator, they lose half a mark, or something. Okay? So yeah, showing your work is important. All right. Do we have time? I think the bell's gonna go any moment. So we'll have to. Kind of annoying, but I think we have one more example. Oh, and then the problem. Well, the problem we could do this when we do the word problems on Monday, but I don't know if we have enough time to do exercise 3. I don't think we do. So we'll have to pick this one up tomorrow. So, but you guys can still do 1.4.